video is for day 2 of reteaching arithmetic and geometric sequences in series. And on day 2, we're exploring exclusively geometric patterns. So there's one example we're going to run through for a few problems. 2 to 6 to 18 to 54, the pattern is times 3, times 3, times 3. Therefore, if you'll remember, the common ratio R is 3 in this pattern. And again, the first term, like it was with arithmetic, is the 2. So number one, expression to find the nth term, well, that will be straight using the sequence formula that's listed above. It's on your yellow sheet, remember. But the nth term, any term, can be found by the first term, 2, times the R value, which in this problem was 3, and raising it to the power of n minus 1. So it's a little bit easier with the formula. There's no simplifying. Remember, you can't take 2 times 3 and make it 6. I get a lot, but you be violating the order of operations and multiplying your 2 and 3 before doing the exponent. So that's just your final answer for the nth term. Now we're going to use that formula basically to find the 12th term, a sub 12. Again, I'm focusing on using the formulas because I find the 12th term by just continuing the pattern times 3 times all the terms listed, and you have your 12th term. But this reteaching is more for the formulas. So when we use the formula, a sub 12, we'll take 2 times parentheses R value 3 and raise it to the power of 12 minus 1. So you'll type in the calculator 2 times 3 to the 11, and it will tell you the answer is 354,294. So that's one way to use the sequence formula. We're also going to skip down to number 5 and use the sequence formula to find the missing terms, geometric means of this problem. The 500 represents the first term. The 4 represents the fourth term. So if the numbers are going to get smaller, 500 blank to blank, you're like 100, 1/4. That's the only way the terms are going to get smaller as you multiply. So let's see what that is. Let's see. We'll put the 4, this 4, in the a sub 4 spot on the left side of the formula. First term 500 goes here. We don't know R, so that's going to stay R. But we do know that 4, coincidentally, is the fourth term. That n value 4 goes in the exponent, 4 minus 1. Then we solve for R. So the first step would be divide by 500 to both sides. And when you divide 4 by 500, I'll model that. 4 divided by 500. Math, enter, enter. You get the fraction 1 over 125. So 1 over 125 equals R to the 4 minus 1 equals R cubed. So then it becomes a hunt for the missing R. What is the thing that you would cube? What is the thing that you would cube to make 1 over 125? Well, you would cube a fraction, and you would cube a 1 to make 1, and you would cube a 5, 125, so 5 in the bottom. Your R is the fraction 1/5. We'll test that out by multiplying 500 times 1/5. We'll get 100. Then we'll multiply the 100 times 1/5 and get 20. Do it one more time just to make sure. Times 1/5. 20 times 1/5. We get 4. Out the two geometric means problem are 120. I believe we scan through here. Yeah, that's the last one that we're going to use the sequence formula on in the teaching. There'll be the your turns down here at the bottom later, but that is all we're going to do with the sequence formula. Now let's explore the sum formula. Number 3. The sum formula helps shortcut adding up the 2 plus the 6 plus the 18 plus the 54, etc. So if you're adding the first 12, you obviously could list out the remaining terms up to the 354,294 that we found and then just add them up. But again, this is just a video to help reinforce the formula. So let's use the formula. Sub 12, the sum of these 12 terms will equal first term 2 minus a 2 times and raise it to 12, divide that minus. At this point, you got to be really careful because we've plugged into the formula. Getting the correct answer kind of depends on the button you push in the calculator, and it's easy to push the wrong buttons. So I'm going to model the wrong way first. 2 minus 2 parentheses 3 exponent 12. If you continue by hitting divided by 1 minus 3, this will not work. By now, I think you guys all recognize the problem with this. You're going to need parentheses around the 2 and the 12 and the 1 and the 3 before it will work. So I'll just go ahead and hit enter, and that's not the right answer. So I personally, the way I would type it in to counter the parentheses and making sure I do it in the right order is when I type exponent 12, I'm going to hit enter. And therefore, I've got the number that goes in the top of the fraction. I'm going to divide it by minus 3. I have 1 minus 3 is 2, so divide by negative 2. And that's the correct sum, 31,440. Careful. Type the wrong way. Number 4 is also, it's a different formula. But if we look at the formula for a second, you might notice that that 3 and that 4 and the n minus 1, it's all looking like the sequence formula. A sub 1 would be the 3, the r would be 4, and the n minus 1 matches the n minus 1 in the sequence formula. So that and start building that pattern. 3 and then multiply it by 4, so 12, multiply it by 4, 48, etc. until you have 25 numbers and add them up. Or we can use the shortcut, which we just used in number 3, to add a pattern. So let's use the shortcut here. S sub 25 equals first term 3 minus first term 3 times the r, which is 4, to the exponent of n. So I'm adding 25 terms, that goes there, and divide it by 1 minus r, which was 4. So that will shortcut this work, although I need to give myself a little more room here because I know this answer is going to be really weird. But we'll type it in, get that answer, and then deal with it. 3 minus 3 to the times 4 to the 25th power, enter. See, there's the e to the 15. This is a big answer, divided by 1 minus 4, a little mental math, divided by negative 3, is 1.2589. Let's get this on paper. 1.125899907 e to the 15. Well, that's a big number. E to the positive 15 means times 10. So we need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. So that'll be 1, 2, 3, 4, 5, 6, 7 more zeros. The number 125899907, and then 1, 2, 3, 4, 5, 6, 7 zeros. That is a very, very big number. I would take either one, the scientific notation version, or the actual answer. But when you're multiplying by 4 over and over again, it doesn't take long for the numbers to get really big. So that concludes the notes part of reviewing the sequence formula and the sum formula in action. So if I were you, I would take a minute, pause the video, and try the 6A, B, C, and the 7 and the 8. I will pause the video myself and start doing some work, and I probably explain a few things as I go, since the geometric is a little more confusing and bigger numbers than the arithmetic, but I'll get some work on the board first. First thing that I noticed, I'm noticing that 3,125 goes down to 625, down to 125. So you may have forgotten how to find r, the thing that's making these smaller. But to find the multiplication pattern, you take the second term and divide it by the first term. You could take the third term and divide it by the second term, but any term and divide it by the one in front of it to find r. And when you do that, you'll find that 625 divided by 3125, enter, turns that decimal into the fraction 1/5. So you have a R value of 1/5. So that'll help you get started on 6A. All right, as you see now, there's some work on the board for 6A and 6B. 6A, any more trouble after you found that correct R, and finding B would just be plugging in a 9 for the n value. So I shouldn't have much trouble with that. But then I'm going to skip over to number 8 because it's the last one that uses the sequence formula, and actually show that work as I do the work. 25,920 goes on the left side of the formula. That's where the fourth term would go. And the 15 goes in the first term spot. And we don't know R. But we do know that 25,920 was the fourth term. So the exponent will say 4 minus 1. So our first step to solving for R, we divide by 15 to both sides. And we get the number 1728 equals R cubed. So then it becomes a guessing game of what would you cube to make 1728. So you'll type in your calculator 10 cubed, 11 cubed. You'll be guessing, but I'll go ahead and show you 12 cubed gives you 1728. So the number that you would cube is 12. So R is 12. We can confirm that by multiplying by 12, filling in the numbers, and seeing if we indeed get 25,920 for the fourth term. 15 times 12 gives us 180. 180 times gives us 2160. And then 2160 times 12 gives us 25,920. So we definitely got the correct geometric means. So again, I'll pause the video again now and work on 6C and 7 because those are sum formulas. As you can see, the work for 6C is on the board. Be careful typing it in the calculator. When you type 3125 minus 3125 times 4 to the 8th, make sure you hit enter there. And then divided by mental math, 1 minus 4 is -3. And then you'll get that correct answer. For number 7, you'll notice the 2, you'll notice the 5, you'll notice the n minus 1. That's in the format of the geometry. Therefore, A1, first term is 2. Second term would be 2 times 5. So 2, and then 2 times 5, 10. Keep multiplying by 5, 50, 250, etc. You could keep going and list, but on formulas. So the sum of the 10 terms would equal 2 minus 2 times R value 5 to the exponent 10 over 1 minus R, 1 minus 5. Type it in carefully, and you'll get 4,882,812. And that concludes the geometric work. Rewind the circuit part again, but the problems that are assigned in the worksheets, you should be able to finish those pretty well at this point. But again, if you have questions, keep them. When I get back, we'll